have been studying about the number system in your previous classes. So we are going to extend that number system in your English class a little more bigger. First of all, before going and entering into the lesson, actually we are going to do a simple activity. Let us do that. What am I writing on the board? Anyone can answer. What are these? Louder, louder. Shapes, squares, figures, symbols, whatever you say. Stand up, please. Can you count each square slowly, one by one? Louder. 1, 2, 3, 4, 5, 6. Thank you. Sit down. So when I asked her to count these boxes, she started assigning the numbers 1, 2, 3, 4, 5, 6. If I will write few more boxes rather than them, you will be counting what? You will be counting. Very good. 7, 8, 9, 10, so on. So what are these numbers called? Very good. Louder. Natural numbers. Very good. Natural numbers. Natural numbers. So every time for counting you use these natural numbers, isn't it?
Yes, sir.
Yes. So as we are counting, as we are using these numbers for counting, we also call these numbers counting numbers. What is the other name of these numbers?
Counting numbers.
Or counting numbers. Very good. This and all you have learned in your 6th class itself. We are interested in extending this collection of numbers. What we are going to do is add 0 to this collection. What are these numbers called?
Whole numbers.
Very good. These numbers called whole numbers. You are quite familiar about this number system. Very good. So, a little more extension we are interested in. What we are going to do now is we are going to add the negative numbers of these positive numbers. What are all the positive numbers? 1, 2, 3, 4, 5, so on. So, how does these numbers look like? We go towards left. How does these numbers look like?
-3, so on.
Very good. These numbers are called integers. Till this you have learned in your 6th and 7th classes. And one more thing, we assign a symbol for each of these collections.
Yes, sir.
Right? What is the symbol for these natural numbers? N. All should be silent. I will be asking the symbol individually. U. What is the symbol for these whole numbers which we represent? Very good. Sit down. Please. What is the symbol we assign for this collection? Very good. Z. I thought you would be. Sit down. Soon after saying the answer, whether it is right or wrong, you be sit down. Okay, I thought you would get confused with the integer symbol. You would say, I thought you would say I. You arrived at the right symbol. Z. So till this you have learned in your previous classes. We are very interested in extending this collection a little more bigger. That is what you are going to study. The collection's name is Very good. Rational numbers. these numbers look like? First time we are reading about these rational numbers, isn't it? In your before classes, you never listened about the rational numbers. You listened about these natural numbers, whole numbers, everything. First time we are learning about the rational numbers. We are interested. Okay, these kind of numbers we have seen in our daily lives also, but we did not see this number. You may think like that. How do these numbers look like? Can anyone guess how do these numbers look like? Anyone? Any example also, no problem. Can anyone? It is open door. How do these numbers look like? No one knows? No one knows? No problem. We are going to study about those numbers only. You will answer that question surely soon after the class. So, we have learned about fractions in your earlier classes, isn't it? Can you tell me an example of a fraction?
Like fraction, unlike
Exam, yes, very good. Like fractions, unlike fractions are two kinds of fractions. Example of a fraction, any real life example, any example? You do not know? No problem, say down. Any example of a fraction? If you do not know, do not worry. You just say, I don't have an idea, sir. I do not forget. I do not remember, sir. You don't know? Very good. Sit down. Any example of a fraction? Sit down. No? It's okay. No one knows the example of a fraction? Very good. Very good. I appreciate the spirit. You please. Can you give me an example of a fraction?
1 by 2.
1 by 2. Very, very good. Sit down. So we have learned about these kind of numbers in the earlier classes, isn't it? So every fraction looks like this. We say every fraction looks like P by Q, where P and Q are whole numbers. Right. Likewise, we have learned about the fractions in earlier classes. So, these are the fractions. Even the rational numbers look like almost similar to fractions. Let me define the rational numbers first, and thereby you yourself will give the examples of rational numbers. What are the rational numbers? You please note down in your notebooks while I am reading the 21 board. I will say any number which can be expressed in form of P by Q, where P and Q are integers. Also, Q must not equals to 0. Can you read out the definition for me, please? Can you read out the definition of the rational numbers which are written on the board?
Any number which can be expressed in form of P by Q, where P, Q are integers, Q equal to 0.
Q not equals to 0. Very good. All of you write down this. So, any number, it should be P by Q. It is not needed. It should be P by Q. It can be transformed. It can be P by Q. It can be transformed into P by Q. Right? If we carefully observe this definition, all fractions comes under rational numbers only, as all fractions will be in the P by Q form. Right? Definitely. See, 1 by 2 you have said. 1 by 3 I will be saying. 1 by 4. If one number should be termed as a fraction, it will be in the form of p by q. Right? In that case, according to our definition of rational numbers, all fractions comes under rational numbers. Understood? No confusion. I'll tell the difference of fraction and rational numbers later, but I'm just saying all fraction comes under rational numbers. Isn't it? I'll tell p by 4. Is it a fraction? Kind of. Is it a fraction? No. Yes, sir. Very good. It's a fraction. Can we call it a rational number? Yes, because it is already fraction means it is satisfying our definition of p by q. Right? P and q are integers. P and q are integers. Right? So it is a fraction and it is rational number also. All of you understood what is a rational number means?
Yes, sir.
Half of our rational number definition is over. Let me say the other half of rational number. Be silent. You. Thank you. What kind of number is this? You don't know? No problem. Sit down. Say it. Yes. Thank you. You. What kind of number is this? Okay. Thank you. You are approaching towards the rational numbers. Sit down. You.
Decimal number.
Very good. This is a decimal number. I did not deny your answer. You are correct. I'll approach towards your answer. Everyone will be agreeing your answer. Decimal number. Did you learn about the fractions completely in your previous classes? Yes or no? Yes. Can you write this decimal as a fraction? No? Sit down. Thank you. Can you write this decimal number as a fraction? No? Sit down. Who can transform this decimal number into fraction? Very easy. You have learned that in your previous classes. Expect the answers. No? No? Okay, thank you.
5 by 10.
Very good. 5 by 10. This is nothing but 0.5 only. Right? So, I transformed this decimal number into fraction. Now this looks like in the form of
P by Q.
P by Q. And this P is nothing but 5. 5 is an integer or not? Is 5 an integer? Louder. Very good. Sit down. 5 is an integer. Is 10 an integer? You? Yes. Even 10 is also an integer. So both are integers. Both are in P by Q form. So what? This is a? No. This is a rational number. Rational number. Very good. This is a rational number. Why? Because this is an integer. This is an integer. This is in the form of P by Q. Isn't it? So 5 by 10 is nothing but 0.5 and this is a rational number. Then can we call this as a rational number? Yes, because if you look back to your definition, any number which can be expressed in the form of P by Q. If you transform the number in the form of P by Q, that is enough for us. Then we can directly call that number as rational number. In that case, I transformed this 0.5 into 5 by 10, which looks like P by Q, where 5 and 10 are integers. In that case, can we call 0.5 as a rational number? Yes. 1.25. Can anyone transfer this into fraction? Very good. As there are two decimal places, you are going to add two zeros in the denominator. Very good. I appreciate it. So this 1.25 is also expressed in the form of p by 2, and 125 is a positive integer, 100 is a positive integer. Both are integers and expressed in the form of p by q. Can we call it 1.25 as a rational number?
Yes, sir.
Very good. You are on the track now. Very good. Let me give another example for this. Minus 125.5. It is little more tricky question than these two examples. What do you say? Can we write this as a rational number? Can we write this as a fractional form? No? No one knows how to transform it. It is similar to this. Can we? Yes? If you say yes also, no problem. If you do not know how to convert it, can be? Okay. No one knows? I will be expressing. Similar to this, just like you have added for two decimal places two zeros, it is similar to remove the point and write 10. Is that enough? Similar process I have followed in these two previous examples. So now 1 minus 125.5 is expressed in the form of minus 1255 divided by 10. This is in the form of, and this is an integer?
Yes, sir.
You please, is this an integer? Yes. All negative numbers are all negative sign added to the natural numbers are integers also. Sit down. So this is an integer. Is this an integer? Yes. What kind of integer among those two sections? Very good. This is a negative integer. This is a positive integer. We are not worried about whether it is negative or positive. Both are integers or not? Very good. Both are integers. Both are in the form of p by 2. So is this a rational number?
Yes, sir.
Very good. So whether it is directly please close the door by your name. Whether it is directly visible as a p by 2 form, like a fraction, focus here. Whether it is directly looking like a p by 2 form, like a fraction, or it is not looking like a p by 2 form, but it can be expressed. It can be expressed as a p by 2 form. Then both are rational numbers only. Do not get confused. A number which can be expressed in the form of p by q is a rational number. Understood? So how big is this set? Let us look. Let us verify through this chart. Do all of you able to see this number system?
Yes, sir.
I arranged this into concentric circles. Let us see how big these are. Do you see the natural numbers in the green color?
Yes, sir.
These are the numbers which you are told at the earlier stage of our class. 1, 2, 3, so on. We have added 0 to this fraction and that became whole number. So this bigger circle entirely is called whole number. Is 3 a whole number?
Yes, sir.
Very good. Is 0 a whole number?
Yes, sir.
Easy. Looking at the chart you can no problem. Is 1 a whole number? Very good. Because whole numbers is the bigger set already consisting the natural numbers. Understood? No confusion?
Yes, sir.
So next is if you look at that, we have added negative signs to the all natural numbers, and this big collection, this entire circle This blue region and this entire circle is called integers. That is represented by the sign Z. That is represented by the sign Z. So little more extension of these integers is called rational numbers. That is represented by the sign Q. The rational numbers. Understood? No confusion. I ask very easy question. Do not get confused. U. Is 0 a rational number? Very good. If you look at this, it is like big book consisting all these pages. The rational number is a big book consisting all these pages. Among that, the natural numbers is like a line in the textbook, line in that book. Among that, the integers are like pages in the textbook. So entirely that term is a textbook. Even the line is a part of a textbook. Even the pages are the part of a textbook. Just like that, all these numbers are the part of rational numbers. What extra rational numbers are having apart from this Z? The fractions, the decimals which can be expressed as a P by Q. That is what this yellow region is. These rational numbers are already having the integers, whole numbers, natural numbers. And in extra, they are having what? These P by Q expressive terms. You may be asking, sir, why don't you said the definition for rational numbers and you are telling the natural numbers, whole numbers, all integers as part of rational numbers. How would this, they are not seeming to me as a P by Q form. You said for a rational number should be separate. For terming a rational number, it should be in the form of P by Q. Right, then very easy thing. What kind of number is this? Very good. Negative integers. I am saying it is negative integers and also what? Rational or natural? Yes, rational numbers. Why? Can anyone justify me? Because it should follow the definition. Definition means it should be strictly followed. It should follow. It is not looking like a P by Q form. Even still, I am saying this is a rational number. I am very sure about this. Can anyone explain why I am calling this integer also a rational number?
If there is no denominator, we can keep 1 as the denominator.
Clap for her. Absolutely correct. Exactly. So, if there is no denominator, we can add 1 as a denominator. We can express this as a rational number. Very good. Minus 4 by 1. Likewise 0 by 1. Likewise 1 lakh by 1. All these can be expressed as a rational P by Q form. All these are integers only. So these all are satisfying our two conditions, which are integers and these denominators not equals to 0. Then simply looking at the definition, simply following at our conditions, these can be termed as a rational numbers. You guys are absolutely correct. Thanks to the answer. That is what I am interested in. So I will be distributing the worksheets. It is just one word answers. I will be distributing the worksheets. Please answer to this. Please sit in that. Quickly answer those two questions. Those three questions. Just try. You may not be knowing. You may be knowing for 100%. Just try. Expect the answers. That's all. Look back to your definition. Look back to your number system of whole numbers, natural numbers, and answer those two questions. Answer those three questions. No, I'll be, if you do not know, you just leave that and go for the next question. I'll be clarifying those doubts on the board, no problem. Completely, thank you. Yes, we need to write on the worksheet. Over. Thank you. Let us discuss the questions given on the worksheets again. So the questions are: write the rational number which cannot have reciprocal. Reciprocal means what? If I say 3 by 5, who knows the reciprocal?
5 by 3.
Okay, everyone knows it. Very good. The reciprocal of it is 5 by 3. Likewise, there exists only one number which you cannot make a reciprocal of that number, of that rational number. It is a rational number, for sure, but you cannot express it as a reciprocal. Who knows the answer? Very good. Come on.
0 by 1.
0. 0 by 1 or 0? 0 by 1 or 0? Both are equal only, right? So, what happens if you make reciprocal? Suppose if you make reciprocal, what happens? 1 by 0. This kind of number is not at all existing. And according to our definition, Q.
Not equal to 0.
Very good. Who is that? Stand up and say it once again, louder.
Q not equal to 0.
Yes, according to your, according to our definition of rational numbers, Q must not equal to 0. In this case, if you reciprocal the number, the Q will be 0. Then it doesn't exist as a rational number. It is not at all a number also. Very good. This is the first question I have given on the worksheet. Next question is justify 0.3. Suppose 3 as a rational number. It's easy. It's just like we have discussed at the earlier stage of the class. It is 0.3 is nothing but
3 by 10.
yes, very good. 3 by 10. And this is a P by Q form. P by Q form, and this is an integer. This is also an integer. We are not interested whether it is positive or negative. Integer. P by Q form. Q is not equals to 0. Hence it is a rational number. Very good. So 0.3 is a rational number because 0.3 is expressed, can be expressed. Looking at the next question, is every integer a rational number? Is every integer a rational number? What do you say about that? Yes. Yes. Minus 1025. Is it a rational number? Yes. Who can justify this? Who can justify this? Not you. Who can justify this? Don't know. It's easier. Minus 1025 is an integer. All integers comes under rational numbers only. As like we know, the bigger set, bigger collection. So this is also a rational number. Who can justify the minus 1025 as an answer, rational number? You can just explain me minus 1025 as a rational number. You, thank you. Very good.
Minus 1025 by 1.
By 1, very good. So minus 1025 is also equal to minus 1025 by 1, isn't it? Does anyone deny it? Does anyone say no to it? No. It is also equal to minus 1025. Sit down, do not answer. Sit down. It is equal to this. And it is integer. Both are in P by Q forms. Hence it is rational number. Hence it is rational number. Let us recall what we have learned about rational numbers. Define a rational number.
1 by 2 or 3 by 2.
Those are the examples of the rational number. What is the definition of rational number?
A rational number has to be in the form of p by q, and q is not equal to 0. And every rational number will be have to be in an integer form.
You are partially correct. Sit down. Can you look back into the book and tell me what is the rational number? One should be telling. Tell. Tell.
Any number which can be expressed in a form of p by q where p by q are an integer, p is not equal to 0.
So, exactly. Sit down. Any number which can be expressed, it should not be 2 minutes. It should not be. It is not necessary that it should be in the p by q form. It can be any number which can be transformed be, which directly looks or indirectly can be transformed into p by q. That is a rational number. Example of a rational number, please. Tell it louder. Any example? 1 by 2. 1 by 2 is a rational number. Integers. Q not equals to 0. Integers p by q forms a rational number. That is every fraction a rational number? Yes. Thank you. We expect this one cooperation in the next class also. Very good answer. Thank you.
Thank you, sir.